Hello everyone, how are you? Today I have got one interesting topic to show you. How can we schedule our EC2 instances for automatically to start and stop? There are two parts of this video. One with general template and the other one with systems manager. Today I will going to show you how can we do it with general template. We are going to create one stack set which will deploy one Lambda function, DynamoDB table, and one event bridge. We can also create CloudWatch logs. So why should we do it? Why should we schedule an instance to start and stop automatically? The main use case is price reduction. In this volatile market, we really should observe our usage and over provisioning. EC2 instance cost is really high if it runs 24/7 and if we don't use spot instances. So in that case, we really need something to stop the servers when we are not using it. Now, if the use case is clear, all we need one automation to do this implementation. For this automation, we have one standard template which we can implement in every account. We are going to discuss that in details. Lastly, if you are new to this channel, kindly like, share, subscribe, comment your thoughts and enjoy this video. So this is a general concept that I will be giving, like what we will do here and what we will provision and how it works. So as I said, I will use one general template. So the template is given in the website and I will also give the link in the description box. I will use one YAML template and that template have everything. So that template actually provision one event bridge. That event bridge will trigger one Lambda function. And that Lambda function will check the time in DynamoDB table, that in which time it has to keep the EC2 instance start and at which time it has to stop the EC2 instances. So there are multiple parameters that we will give in DynamoDB table, like if it is an office hours, if it is weekends, if it is weekdays, various types of things we can give into this DynamoDB table. And according to that, the Lambda will pick up that particular parameter from DynamoDB table and it will start and stop those EC2 instances. Now the question might be that how the Lambda will know that this EC2 instances it has to manage. So very simple, we have to tag the EC2 instances in a particular name in a way that this EC2 instance is related to this DynamoDB table. So in our DynamoDB table, we will create one entry with the tagging value, and that tagging value we will give to our EC2 instances. And those EC2 instances which will have the tag Lambda will pick up the EC2 instances, and according to the time that we have given in the DynamoDB table, it will start the instance or it will stop the instance. So the CloudWatch log is also kind of optional. You can enable it, but if the Lambda is running, anyway CloudWatch logs will be enabled, and Lambda, we all know that Lambda puts everything into CloudWatch, so the CloudWatch logs will be there. So again, so the architecture is that event bridge at a time, we will keep the event bridge scheduler at 1 minute. Event bridge will trigger Lambda. Lambda will check for the time in the DynamoDB table, that if the time zone is something that it has to start or the time is something it has to stop those instances, and it will search for that tag of those instances, and if it found the one EC2 instances with that tag, it will start the instance or stop the instance according to the time, and it will eventually log everything into CloudWatch. Now the question is, why are we using a template? Can we create everything by our own? Yes, of course we can create everything by our own, because these are everything that we can create. DynamoDB we can create, Event Bridge, Lambda, CloudWatch, everything we can create. But the thing is, if we need to create everything from scratch, we have to create a lot of things. So basically, the template will also create some IAM policy and IAM role that currently I am not showing here in this, but I will explain the YAML template that it will create. So we don't have to manage the policy, or we don't have to take care of the policies that it will create, or the Lambda needs permission to start or to stop EC2 instances, so we also don't have to do that. So in case we create the whole architecture with this template, then we don't have to take care of all of the permission or the role or the policies and everything. So everything is there already. We just have to provision it. So in an organization perspective, if this is an one particular account, this is fine. This is very easy. From an organization perspective, it is also easier to deploy this template as a stack set deployment for an organization. So we can automate the provisioning in an organization, and every account within that organization will have the stack set deployed, and it is an automated way. The Lambda will trigger the EC2 instances according to the tag, and it will start and stop those instances. So that's all overall process. Now we will go to the YAML template and let's see what it does. So this is my template. The template is already uploaded here. This description I will give in the link I will give in the description box. You can download the code there. So this is similar to this one, which I have just opened with VS Code. So let's look at the template and let's see what it does. So at first, it will create from AWS Event Bridge. It will create one rule. So we can search event, and we can see that AWS events rules will be created. So this rule is instance scheduler rule to trigger instances scheduler function. So this event rule will trigger the Lambda function. So this Lambda function it will trigger. Now if we see the reference here, the target is main ARN and the target 0. That means this is we have to find in this main method, or we have to refer to this main, and from there we take the ARN, and from that ARN we need to take the ID, and this is the target. So we can search with Lambda function. So this is the permission, and we will search with Lambda function. This is my function, and what we can see here is this is the main that we were talking about. This is the resource, and from there the event rule will refer to this Lambda function, and this Lambda function actually takes the code which is already there in this GitLab report in this S3 bucket instance scheduler zip, and it will unzip the function, and then it will actually try to access the instances, and it will try to schedule it according to the DynamoDB table. So this is the Lambda function that it will create. Apart from that, we will create one DynamoDB table. So if we search with DynamoDB, this is the DynamoDB table that it will create, and it has attribute. It has couple of attribute there. So there are actually 3 DynamoDB will be created. One is instance scheduler config table, one is maintenance window table, and another one is scheduler event rule table. So these are 3 DynamoDB table it will create, but we need to change the time in one particular DynamoDB table that I will show you. So this is the overall architecture, and the one that I was talking about mainly what is the benefit of using this template is that it will create the policies. So if I search for IAM, so it will create lots of IAM policy and IAM role automatically. So we don't have to bother about that. We have to create one IAM policy so that event bridge can trigger Lambda function, or Lambda can access EC2 instances, or Lambda can access DynamoDB table. So we don't have to take care of all the IAM role and policy. So this, if we use this template, everything will be created automatically by this template. All we have to do, we have to create some EC2 instance. We have to tag them according to this diagram. We have to tag them according to the one that we will create in the DynamoDB table, and that's it. Then the DynamoDB table, the Lambda will pick up the time zone from DynamoDB table, and it will schedule it. So what we will do, we will upload this template. So let's go to our management console, and I am going to CloudFormation. Inside this CloudFormation, I will upload one template. I will say that template is ready. Upload a template file. I will choose it from desktop. This is my template file. And if everything is fine, it will go to the next step. So I will give it a name called automation stack set. So please check this one, that instance scheduler tag name. This is the tag name that we have to give, and we have to tag our EC2 instances. So this is fine. And for RDS snapshot, we are not going to do anything with RDS regions. I don't specify any particular region. So the default time zone is UTC it is taking, and the cross account rule, we don't need it right now. So we can create cross account rule to deploy this template cross account wise. Schedule instance in this account, this is fine. We can select no as well. When if we select no, then it will not be scheduled in this account. So memory size is fine, and enable CloudWatch logs. So as I was saying, like, yeah, we can enable this CloudWatch metrics optionally. This is not mandatory one, so we can either provision yes or no. So I will provision as of now it is no. Then we will check if lambda is creating or that or not. So this is fine, and these are other parameters that we have to give. That's all actually we have to. So I'm not changing anything here. I have only given the stack name, and that's it. I will click on next, and for this stack I don't need currently any tag. And for IAM role, for the stack creation, the IAM role, I will leave it to AWS and create it by its own. All I have to give is next, and then I have to acknowledge something here, that AWS CloudFormation might create IAM resources. This is fine for me. Sorry. And then I will submit. So it will take some time. What I am going to do, I will pause this video and I will come back when everything is ready. Okay, now I can see everything is created here. So let's take a look. So we have our DynamoDB table created. So as I was saying, lots of IAM policy, KMS key, IAM role, SNS topic has been created. We don't have to bother about anything about it. So lambda function is created. Three should create another DynamoDB table is created. So 3 DynamoDB table is created. AWS events rule is created. Log group is also created. So what I'm going to do, let's go one by one. So first, let's go to this event bridge, then go to Lambda, then CloudWatch, and last but not the least, let's go to EC2. So our event bridge, if I go to rules, and here we can see that automation stack set scheduler rule has been created, and this rule is currently enabled, and I can see the rule trigger point is within 5 minutes. So what I'm going to do, I'm going to change this rule, event triggering. So this rule will be triggered in every 1 minute. So every 1 minute, this rule will be triggered, and it will trigger the lambda function. So the lambda function then will check if any instance need to be either stopped or start. So then it will decide, and it will start and stop the instances. And another thing I forgot to mention is that the DynamoDB table. So let's look about the DynamoDB table. So this is the DynamoDB table also is opening. Okay, fine. So scheduler, I will going to change it. So this is fine. Now let's go to Lambda, and I can see this main Lambda function is created. And this Lambda function is nothing but, we don't have to look into the code of this Lambda function. All it does, it takes the time from the DynamoDB table, and according to the time, or it check the tag from the EC2 instance, and then it will schedule the EC2 instance for starting and stopping. So we can go to the CloudWatch then, and we can go to log groups, and we let's see what it has created. And in the log group, I can see the Lambda automation stack set instance scheduler log group is created, but I hope there will be no logs. Okay, there are 2 logs. because our event already been triggered. So that's why some logs was there, but I don't think any EC2 instance it will find. Yeah, there are no EC2 instances. So this is fine. The log group is only created. And our EC2 management console, let's see if we have any EC2 instance. Currently, we don't have any EC2 instance. So this is fine. Now, in our DynamoDB dashboard, we can see in the table section, there are three tables. One is the state table, one is the maintenance window, one is the config table. So if I open the config table, explore table items, and if I come down, I see that there are a couple of name that is given. So if I want to schedule one Lambda function, or if I want to schedule one EC2 instances with Seattle time office hours, so we can use this name tag in our EC2 instance. It will be scheduled automatically. And how it will schedule that? So Lambda will first check this one, Seattle office hours, and then inside schedule it will check the period. The period is office hours. Then it will come here and check the period office hours. And in office hours, it will check the time. So the begin time, that means the EC2 start time will be 9 a.m. and the stop time will be 5 p.m. in the evening. So according to that, it will start and stop EC2 instances. So there are relation between this schedule and the period. So the period depends on the schedule, and Lambda will check both schedule and the period. So if this is clear, then what I am going to do, I am going to create two EC2 instance. So let's create two EC2 instance first. So I need two instance, and the name I will give Linux for both of that. So I will select Amazon Linux, and then I don't need any key pair right now, and everything else is okay. And then I will launch the instances. And what I'm going to do, I'm going to proceed without key pair, then proceed. So let's go to EC2 dashboard, refresh, and I can see both of the instances are in pending status. So I will come back when both of them are in started. Now I can see both of my instances are running, or at least this one is initializing still, but both of them are running. Anyway, so why I have initialized, or why I am running two instances, because one of the instances I will show you that that this is working when I am tagging the instance, and the other one will still be running, just to show you that our tagging is working. Okay, so the first step is to go to our DynamoDB table and let's check the attribute. So I can see in schedule couple of attributes are there, like Seattle office hours, UK office hours. What I will do, I will create a new entry, or I can just duplicate this one. Duplicate this one, and then right now I am in Europe, Berlin time zone. So I will use Berlin as my time zone, and right now it's 7:49 at night, 7:49. So according to that, I will give it as DE, Deutschland, and then office hours in Germany, and then in this field and the time zone I will add it as Berlin, because if you see my time zone is Berlin. So in Berlin, so this is the time zone that I want, and this is the name. This is the name that I have to tag my instance with the key is schedule. How I find out this one? If we search for schedule, and let's look for this one, and here you see that this is the tag name. So my EC2 instance tag name will be schedule, the name of tag used for associating instance schedule with service instance. This is fine, and my value will be DE office hours. And if you see here, this is the reference of periods, and it will take the periods from office hours, and I will create the item. and then I will check here for the period. And if I open period, this is the original stack set deployment. It is already at 9 a.m. every day. In office hours it is running the instance, and that is the begin time, and the stop time for the instance is 5 p.m. I will change it. What I will do right now, my time is 7:51, right? So I will give it as maybe 7:55, that is 1955, and then I will start the instance at 1958 maybe. So at 1955 it will start, or it should start the instance, or if it is already started it will do nothing, and again at 1958 it will stop the instances. So that's it. Now let's save changes, and I can see my period is updated 1955. Right now it's 1952, so we have to wait for 3 minutes. And within that 3 minutes, what I have to do, I have to update the EC2 instance. I will go to the instance, and first of all I will select any one of that. So this one maybe, and I will go to tags, manage tags, add new tag, and schedule, and then I will refer to our DynamoDB table item DE office hours. So it will, so this instance will be start and stop according to DE office hours. So I will save it. That's everything. But I will also, for sake of this video, I will also change the rule for this event scheduler. What I will do, I will edit this one and I will schedule it only 1 minutes. So within 1 minute, it will be triggered. So the event will trigger the Lambda function. In the next step, the Lambda function is automatically taken up. I will give everything as default, and I will update the rule. So within 1 minute, every 1 minute, this scheduler will trigger the Lambda function, and the Lambda function will check if any EC2 instance have this tag, the tag that we have given, and if that instance have the tag, and then it will check the office hours, the hours that we have given in the DynamoDB table, and if the time matches, it will start or stop the instance. So what we will do, currently we will wait. So it's like right now 53, we have to wait for 2 minutes more. So I can see the time is now 1955. So according to our DynamoDB table, it should start the instance if something is not started. So as both of my instance is currently running, as of like the tagged instance is already running, it will do nothing. Now if we see the DynamoDB table, it will stop the instance again at 1958. So what I'm going to wait, I'm going to wait another for 3 minutes, and then I will come back and we will check if this instance is currently stopped or not. Now we can see, as I refreshed this one, at the time is currently 7:59, and I can see my instances are currently in stopped status. So at 9:58 it triggered the stopping of the Linux instance, and it stopped the instance. Meanwhile, we have checked for the stopped category, right? But we did not check about the starting position. So what we are going to do, we are going to change this one. So I want, so as my time is currently 8 already. So what I'm going to do, I'm going to tell, hey, please start my instance at 2 o'clock, and then stop the instance at 8 and 4 minutes. I will save the changes. Then at 8:02, it will start the instance. Right now it's 8 o'clock. At 2 o'clock, it will start the instance. Then again, what is stop, and it will stop the instance at 8:04. So let's wait for 2 minutes. So my time is currently 8 o'clock 2 minutes, and let's see, let's refresh couple of times here. Okay, now I can see the status is pending at 3 o'clock. So the status is pending, that means my instance is coming up right now, and it is done automatically. My tag is still there, so it pick up the tag and it consulted the DynamoDB table, and DynamoDB table said that yes, this is the time you should start the instance, and my instance is starting up. So again, as per DynamoDB table, at 8:04, it will stop the instance. But a stop part we have already seen. So this is the scenario that I wanted to show. Like how can we automate the process of provisioning an EC2 instance from automatically starting and stopping. So I hope you enjoyed this video. Please share your thoughts in the comment section. I will be back with the second part of this video, where we will schedule the EC2 instances to start and stop from Systems Manager. Till then, take care. Bye bye.